how to find out Kp and Kc and their relation from a chemical reaction. Supposed to be this is the chemical reaction when all the compounds are in gaseous phase. Here I have written 2SO2 plus O2 will be in equilibrium with 2SO3. The individual number of moles N is equals to 2, 1 and 2. Thus, the change in number of moles delta N, that will be product minus reactants. So 2 minus 2 plus 1, 3 equals to minus 1. At initial condition, when time t equals to 0, supposed to be the SO2 present A moles, O2 present B moles, thus the product will be 0 as reaction has not yet been started here. For time t equals to Tx for an instant, supposed to be x moles of O2 has been reacted. Thus, it captures the twice to that moles of O2, that is 2x moles of SO2 reacts in this reaction. So, the remaining amount of SO2 will be A minus 2x. Thus, remaining amount of O2 will be B minus x. And the product concentration, that is the SO3, will be produced. The quantity is 2x. Now, the total amount of moles will be summation of these three, that is A plus B minus x. The partial pressure calculation, that is nothing but incumbent pressure, supposed to be, that is represented by capital P multiplied by individual mole fraction. For SO2, the mole fraction will be in the numerator A minus 2x, there's quantity, divided by total number of moles, that comes from A minus 2x plus B minus x plus 2x. All total will be A plus B minus x. Similarly, we have calculated for O2 and SO3. Now, the molar density, where capital V represented the incumbent volume of the system and A minus 2x is the corresponding molar concentration, the molar quantity of SO2. So, the molar density will be A minus 2x by V for SO2, and for O2 will be the molar concentration in the numerator divided by volume in the denominator, and similarly for SO3. Thus, equilibrium constant Kp corresponds to partial pressures will be small p of SO3, partial pressure of SO3 square. These two comes from here, the coefficient of SO3, divided by p partial pressure of SO2 square. These two comes from here, the coefficient of SO2, and the coefficient of O2, as it will be 1, so it will be simple PO2. Putting the individual values of the compounds, we will get this after simplification. For Kc, the equilibrium constant corresponds to the concentrations. Here in the third bracket, we have represented the individual concentrations. That for SO3 will be SO3 square. This 2 comes from here, as 2 is the coefficient. For SO2, 2 is the coefficient here, and for O2, this will be 1. So, putting those values from here, we will get this term. Now, if we can calculate the relation between Kp and Kc, Kp is this term and Kc will be this term. So, Kp multiplied by P will be this term multiplied by V equals to Kc as per our problem. So, Kp will be Kc into P into V, Pv to the power minus 1. Considering ideal gas, Kp equals to Kc RT to the power minus 1. Minus 1 is nothing but delta N. So, Kp will be Kc into RT to the power delta N. This relation stands for our chemical equation, which is a established equation.